Hello, welcome back to BlenderSushi Live Noding. In this video, I'm going to attempt to create this the milipede or centipede kind of setup using sphere chalk. So as you can see, this is the node setup. It looks fairly complicated, but actually it's actually fairly simple somewhat. You will see the final result is something that's looking like this. So the millipede or the centipede is basically this kind of scary looking creatures the, with segmented bodies, and then it has multiple legs. With the centipede seems to have just like a two pair of legs per segment, and the millipede seems to have more legs. It's like 2 legs per segment, and this guy more rounded. He's got rounded head, and then we're not gonna worry about the details, but kind of roughly get the idea about these creatures. Basically, it has multiple legs, and that's the real thing. And I check on YouTube, and there's this really good video. It's in slow motion as well, so we can kind of tell. We can see how the legs moving. That's how this creature is doing the locomotions. This is a very good reference. I highly recommend you to always do that. Look at the legs. It's just moving in the kind of sine wave. It has like multiple segments, but we probably don't care too much about the segments. And then there's the variations on the length of the legs. And when the character is walking, the legs will kind of lag behind because they need to step on the floor, right? So that's just a quick look on these creatures. We're gonna try to recreate it from scratch. This is the one. This is the finished version. What did I call it? Pipe snake. Okay. Let's start from scratch. File save as CentiMiliPede. This is a sphere chalk tutorial. I just figured out earlier today. I was thinking about modeling, and then rigging, and also animation. I was thinking about all that, and then I realized that sometimes if you set it up, if the tools like sphere chalk or animation nodes have the right nodes, you can actually do the modeling and animations without the need to use the skeleton or bones in order to create the final animations. That's actually quite possible, because in the end what you want is just like a mesh that's deforming into your need. Maybe in the 3D scene you have like a curve, and then you make the curve. The curves will be like the actual rig itself, but you don't actually need the bones. It really depends. Sometimes you do need the bones, because the bones, let's say if your character is doing like a kinematics kind of walk, it needs an IK, and then if it's like a spline, maybe you can just use procedural kind of setup. You don't actually need to rig in a way. It's like a kind of a question mark. I mean quotation mark. Okay. Anyway, let's get started. Delete the default cube and sphere chalk, new nodes 3, and then I'll start with a line because I know the character, that creature is like a line. So viewer, draw, check it out. So this is the base of our creatures. You can of course make a really rough kind of model where the creature is like just like a stick like this, but I used to do this, but I don't like it because I wanna start to think about the form. In a few years ago, I was thinking everything can be just we can use skin modifier, and that's kind of true. You can turn this stick into skin modifier and then rig it that way. But if we could make a form inside SketchUp, why not? At first I was thinking to use pipe. Pipe is kind of I think it's a beta kind of node. Sometimes it crashes, but I'll show you real quick. This thing does something. So this thing does that. We can adjust the scale. Yeah, okay, that's like the segmented. So we can adjust it. So it looks like a milipede or centipede. We can turn it into rounds, more like a like a cylinder, squash cylinder. Don't hit bake. I think it's gonna crash. It's a little bit buggy. Don't use the pipe. The pipe itself, it's I think it's a bit I don't know. It's not complete, or it's a complete as it is. It can be useful, but the one I'm gonna use is duplicate objects along edge. This is really cool, powerful node. Whoever made this, I really give a two thumbs. Basically, with this one, with this node, we can create the milipede. It's kind of the nodes to create milipede, centipede. Yeah, basically, we just need to plug the line into the receiver, and the donor can be anything. The donor can be any kind of objects. I will use box for now. So let's have a look at the result. If you use box, you can probably kind of guess what this does. So it's duplicating objects along edge. So obviously, any kind of objects. It's a fairly simple, I guess, but this can do a lot more. Let's see. This is the default of the node. It has count of 3. I will turn it into 1, and then I give it a little bit of padding, so we can tell this is like, okay, this is kind of the segment of the millipede or the centipede. So that should be cool, and we can actually change it to, let's say, cylinder. Whoops, it's gonna crash. No, it didn't. Cool. Cylinder, and then the receive is a line. Plug this to that. Plug this to that. And we can change the axis, I believe. I think one of these sometimes doesn't seem to work, but anyway, it's a trial and error, because of course I was joking that I said this duplicate objects along edges for the millipede or centipede, because most of the nodes in SketchUp, it wasn't a single node that only does one thing. It's a function, and you can kind of put together just like a Lego toys. You put together and you can create like a unlimited kind of setup for all kind of purpose. Okay. So yeah, let's make a centipede using this guy. I will just use back to using box. Okay, this is the box. It's we need to squash it somewhat, so I will use a matrix apply. Okay, that's correct. And then I will use the matrix in and plug in the vertices, and we're gonna squeeze it using scale. So 1, 1, 1 is like this. I'm gonna squeeze it in the Z. Okay, that's can be the starter for our centipede or millipede. How many should we have? 16. Okay, that should be fine. First, I will do the things that a centipede or millipede might do. It's kind of like this kind of shape, like S shape. You know, they have segments, but their body, I think, curl up and doing sort of funky thing. I will do that using SketchUp. See, and it's actually quite simple. You basically just need to put a math here. again it's doing the sign thing, but of course here I'm doing the wrong thing. You see, this is a vector, this is a float, this is a single value, this is expecting um, like a 3 value. Okay, this is really wrong. So we need to actually separate the vector and then put them back together again. Vector in, and there's here something probably kind of tricky. Okay, by default the line actually grows in the x-axis. I already mentioned this multiple times. You can make it goes up if you plug the x into the z, something like that. But we don't want that. We want the x to go into the x. But what we want, we want the y kind of doing the sign kind of thing. How do we do that if the y actually 0? The y and the z is actually 0, 0, 0. We can just plug in the x into the y, but we're gonna use math in between. So x into the sign and then the sign into the y. Now it's making this kind of snake kind of structure or kind of design. So that's exactly what we need. It's very very simple. You can have more or less. You can have like a really long centipede or millipede. Let's keep it like 16 or something. We can adjust the stepping, so that's really cool. We might need that. The stepping actually changes with the along the edge as well because of this node. There is also one thing that I want to show it to you. If we actually use a vector math here and then add it and then plug in a vector in, if we do that and then I increase it in x, you see what's happening? It's moving. It's just like a snake moving. And then if I use a frame info in there, this guy is gonna travel that way and then it disappears. It's escaping. That's maybe something that we want to do later, but not now. For now, we really want I really want is to kind of I want to move the sign, but I don't want it to escape from the screen. So how do we do that? We can simply use math right here and add a number, and then now if I use a frame, plug it, now it's a moving, but it's not escaping, you know. It's just doing the wave kind of thing because of the sign. And of course here I can also do the multiplier and then make it so that it's move a little bit slower. And then one more thing, excuse me, if we use a multiplier here, we can control the actual the amplitude. Although doing it like this, it's kind of the body is stretching, so we don't want that. We don't want that too much. I guess a better way is to adjust the stepping of this line. So that's more or less like the centipede, but it's a very aggressive one. It's kind of like a snake. That's okay. We can keep it like that for now. I gotta give a yellow color for the center of the body. And now I will start to think about the legs. File save as new version. Okay, stop it. Now for the legs, I was earlier today I was trying to use the duplicate objects along edge for the legs, and apparently it doesn't quite work that way. And what we can use, however, is the matrices output from this guy. because what this node does is, if you have this kind of path, it tries to kind of fill the path. So if you give it like a leg, you're thinking, okay, give it like a leg, something that looks like a leg. The legs will kind of stretch, so it's not gonna work. But we can use the matrices output from this guy, which is quite interesting. It's probably new. Let's try. If I plug that into there, and then let's generate something that looks like a leg. You can do this in many different ways. I guess for now I will just use another line. Okay, another line, and then I'll plug this into that and give it a color red. And let's check this out. And now we can already see it's working. We have this segmented line. That's of course we can randomize, but it's a one side of the leg, so you can adjust the length. I wonder if I just randomize. No, random it's not gonna work. I'll just gonna keep it something like that. Keep it simple for now. So we have the leg of our creature so far. Currently the pivot seems to be in the center. We don't want it. Let's move the line slightly to the left. So we're gonna use matrix apply once again, and then use some matrix in, and then use the vector in, and let's move the legs slightly to the left. I'm gonna turn this into wireframe so we can see the inside. Okay, that's this is like the basics, kind of like the cage or the skeleton of our creatures. Let's plug this into the location, I believe, and then slightly move in the X. Now the object's pivot is at the edge right there, and so we can adjust the leg. It's too long at the moment. We can further do something with the legs. You know that we can just replace the leg with a proper legs, right? So we can do that later. And to do the legs, the other side of the legs, we can do that a little bit later. It's just fairly easy. Let's think about the motion of the leg. The motion of the leg, we can simply actually just use the angle. Oh, by the way, we can actually adjust the count. See, in one segment we can have 2 legs like that, just like for the centipede, I think. Or we can have more, so it's a more kind of scary looking creatures with more legs. For now, just maybe keep it 2. Padding, we can have padding or not. Maybe just a little bit of padding. Yeah, I think that's pretty alright. Let's do the angle. With the angle rotation, let's guess. Okay, we need to rotate the legs. And the axis we need is the Z. I can see it from here. So the Z axis plug into the rotation, and now we only need to worry about the angle. For the angle, again, we need to use a sine wave. Let's do that real quick. Another frame info node, and then a float math. Sine wave, plug in the time, goes to the angle. Now it's moving, but it's moving only in 1 degree, only 1 degree kind of angle. We want it more, so map the range. Alt min, alt max, -1 and 1. Now make it like between -36 and 36. So So now the leg's moving. It's moving a little bit fast, so I will slow that down. Slow it 0.2, 0.4, 0.3. Okay, I think we're getting somewhere. Of course, at the moment, we don't have the head and the tail of these creatures. We can easily do that in spare chalk, just separating the top and the bottom part. This creature is basically 100% procedural. It's kind of perfect for this a spare chalk kind of example. It's doing the sign. We can actually have more frequency with the sign, so I can make it goes like 4 times. So now the leg's doing the sine wave, but each one of them is kind of doing the same thing. We need to kind of offset the legs because they shouldn't move all at the same time. Now we need to offset it, okay? And how do we do that using spare chalk? Apparently, you only need to provide the add. So you use another add, and we have this frame coming in. Of course, if we add this time using like a frame range flows, and let's see, how many legs do we have? I don't know. I'm just kind of guess. Maybe give it a count of 20 and step it. So for each iterations, the leg's gonna kind of 5 steps ahead probably. Start at 0, 0, 0. Let's plug this into here, and then now we don't actually see anything. But if I turn on the vertices, we can see that the legs now having kind of offset. Now what's happening here is this is because here we are conveniently using the matrix of this node, duplicate objects along edge. Here we only providing a single edge. You can see the matrix 30, so we should actually give like a maybe 30 here. 30, okay, that's correct. We have to make sure the number is the same for the edge as well. So I will create a list repeater. This is to repeat the edge informations, and by doing that, now we have the 30 legs. Each one of them is moving kind of offset offset by 5 frames. The legs probably moving a little bit too much or something. It looks a little bit funny, so I will make a little bit of changes. Let's try maybe stop this character from moving for a bit. Okay, that's what's the legs moving at the moment. That's actually pretty interesting looking. Maybe because of the clamp. Yeah, it's because of the clamp. So the legs kind of moving in a robotic kind of way. That's probably because of this. I put this in the wrong, kind of put this in the wrong place, but this might be useful actually. Because the leg doesn't just move. This one just keep moving, you know, like a kind of floaty. But if we put like something like that, now the legs kind of staying for a few seconds, kind of like walking. If I add it here, you will see. Maybe I have to put it somewhere. Maybe here. Okay, here's controlling the motion of the leg. Yeah, It looks like the character is walking. Let's see. We can zero this out, and maybe I can have more segment. Maybe 3. That means we need to give it. Okay, apparently there's 45 of these objects. If I want to ensure the count is always correct, I can count the number of these matrices. Just count the number of this, the total of these matrices. Use the list length and then simply plug this into the count. And this one also. So it will always be correct. Although, did I did something wrong? Wait, list length, and get the matrix data, and then check it using the stethoscope. Okay, the level needs to be 0. Okay, plug this into that guy and plug this into the count. Now the number will always be correct. I can have more segment or less segment. It will adjust accordingly. Seems like it's moving a little bit fast, maybe because of the stepping. There you go. That's kind of that what I was kind of wanted to see. This is more like a centipede kind of legs. There's kind of a wave, noticeable wave. If I want to be more if we want to make it more detailed, of course we don't just rotate it in the z-axis. We want to also rotate it in the x-axis. Maybe we can do that as well. You can see here that the legs being copied using the transformations kind of copy, like a cloning, while the motion of the legs is using this this matrix apply. So it's kind of it's the mesh, the actual mesh is actually deforming. This is really cool. Normally it's kind of hard to think of this. If you want to do this using animation nodes, it might be possible, but there will be a lot of different kind of thinking behind it. It's frozen for a little bit. I think. Okay, I shouldn't play back and then create that nodes. Anyway, let's actually rotate the legs in the x-axis. So it's getting tricky but of course you're adding layer of details each time. It is not very simple, but because it's kind of logical. So let's have a look. Now the legs kind of doing that. So it's very doesn't look quite right. It's in the X or in the Y. So Y seems to be making it ups and down. Maybe it's in the Y. but not too much. Maybe minus 10 and 10. Yeah, I think, yeah, that's exactly what I want. Seems to be moving it ups and down. I'm not only rotating it. Interesting, it might be using the pivot of the original object. Well, anyway, I think that should be okay for now. Still looking quite believable. Let's multiply a little bit more or less. Yeah, I guess that's quite alright, quite decent. Now I will just copy this setup to for another leg. Supposedly we can use monad for this, for the other legs, because we are copying this bunch of stuff. I think I can use the C and then select this guy, select all this, and then hit escape, and then move this guy slightly like that, and then rotate it. No, stay. That's I'm gonna copy the whole thing and mirror it for the other legs. I should have paused the playback because I think SpreadShop is now a little bit frozen. Blender is a bit frozen. I think anyways, seems to be working still. Let's stop the playback. Okay, now I'm gonna mirror it for the other legs. Let's see. So that's the time. Just plug in the time into that thing. Now it's our setup seems to be broken. Wonder why. Oh wait, we have time connected to that guy. Okay, we need the matrix to be plugged in that guy, and then our legs is being created now, and plug this into the time, which is that guy, and update it. Still, it's not working. I will make this full screen and have a look. So this is the legs for that guy. We have this. We have the matrices, alright. We have the line, and it's not being copied. Okay, I know why. I know why, because the we need to plug in the matrix into the other nodes. But but of course the position of the legs is in the wrong place. It should be on the other side, so we need to move the legs into the other side. Wait, how do we do that? Okay, apparently it's just these locations. Minus 0.5. And This should be minus 0.82, and I believe now we have the mirror of the other side of the leg. Save this and then play back. Yeah, it's just doing the mirror. Maybe it should be maybe we should offset it in using the time. So we have the time coming in. Let's offset it by dragging the start frame. I'm just looking at the legs motion and the wave. It should be kind of the opposite. Okay, now I think it's pretty much there. Let's bring back the wave, and this one, that's the one. Okay, that's too much. 0.4. Okay, there you go. That's our basic centipede. Of course, the currently it's just like a you know, swimming. It's not really. I think the legs can be. We can add more details to the legs, and the body can be, you know, instead of the box, we can use a maybe rounded box. Let me try. Currently, the legs is just a stick. You can turn this into, you know, segmented joints. But for the box, okay, this is the box being scaled and stuff. Let me try rounded box. Let's replace this box with a rounded box. Rounded box. The rounded box needs this vector in. So by doing that, we don't actually need we don't need to do this matrix stuff. Rounded box is more robust, I guess that's the word. Let's turn this back into solid objects with no wireframe, shade it. So that's our rounded box, but I need to probably squeeze it. Radius 0.2. It's kind of interesting that it's become yeah, there you go. That's what I was thinking to do. Radius, the radius seems to be affecting the roundness, so it's looking like that earlier. So if I squeeze that, okay, that's more like centipede kind of looking. Maybe if I can flatten it more. Well, I cannot flatten it anymore. We might still need to use the apply matrix. Gonna do that again anyway. Matrix apply. It's not a big deal. It's matrix in, vector into the scale, and scale is in the z 0.2, and then plug this into the vertices. Now it's more flat, and it might need to be a little bit wider. Okay, so now we have our centipede. Playback. Okay, currently we have 3 per segment. Maybe we just have 2. That's more natural, I guess. And then we can have more or less number of segments. It's not a problem. We can adjust the stepping. You see how it's all adjusting. It's a beautiful setup. Once, basically with a procedural kind of thing, once you have it ready, you can just tweak the number and it's gonna update accordingly. So that's yeah, that's pretty much what I want to show it to you in this video. If we make we did this earlier. If we now use the vector math in the line, where's our line? This is our, I think this is our line, and then there's a vector ins and blah blah blah. If we use a vector math in here, I believe, add vector there, and then plug this into the x. It's gonna move. Let's give a multiplier 0.2. Now our creature is gonna move. Move a little bit faster. Now, okay. There we go. That's our basic centipede kind of design. Of course, maybe the legs need a tweaking, so it's doing a better kind of motion. At the moment, it's a little bit off. Maybe the gap is too big, but yeah, we have all the concept right there, and we have beautiful sine motion for these creatures. We probably need to add the head and then make sure it has the tail, and the legs need to be, betterly designed. But yeah, that's the setup. It's I guess this should be useful if you're making these kind of creatures. But anyway, thanks again for tuning in to this video. And subscribing to this channel. Hopefully this is useful for you. Enjoy this new skill. I will probably save this setup somewhere online. Yeah, I guess I'll